This screencast is intended to support the BPM 2019 demo paper on extension of process mining on streaming framework in the process mining toolkit ProM with enhancement in the visual analysis of the process discovery algorithms. For more detailed information on the process mining toolkit ProM, we refer to www.promtools.org. The data used for this demo is the BPI Challenge 2017 dataset, which pertains to a loan application process of a Dutch financial institute. The next step is to import the data into ProM, but before we do this, we make sure we have the required packages installed required for streaming data. We have downloaded ProM Lite version 1.2, which requires Java 7 or higher. The ProM Lite version 1.2 is a recent release. Now it is June 2019. We make sure we have the runner-up packages installed of version 6.9.111. We have now started an instance of the process mining toolkit ProM Lite, and we will import the data that was shown earlier called log.xes. And we click on OK. We keep the log selected, and now we start a plugin which generates an event stream from the static log that has been imported. We press the play button and we see a list of available plugins. We make sure that we have the log as input, and we will choose to execute the plugin called generate event stream. We now click the start button, and we can now configure the stream by choosing whether to tag the order of events within a trace and to tag final events in a trace or not. We can set the emission speed to a required value. Here let's choose to change this value to 20 data packets per second, and we can choose to include all additional event data elements or not. I leave them at the default selection. When I click on finish, we trigger the stream generator. We now get the node for starting the stream using the start button. When I click on the start button, data packets are emitted based on the actual process execution captured in the log. Lots of data packages are generated, but with a delay because we took time to click on the play button. But for the purpose of demo, the number of packets chosen to be generated per second is kept low. So we keep this running and we go to the main workspace. We see that the stream generator has produced an XS event output. We will connect the XS event output to the plugin that we have created by clicking on the play button. This plugin is called Compare Accepting Petrinet, Inductive Miner, and Alpha Miner. I click on Start. We see that we have a panel to choose the case and activity identifiers. By default, the case identifier is set to trace, and the activity identifier is the name. I click Next. And here we have the panel to configure event stream to directly follows abstraction reader. So here we see two data structures. The data structure referred to an array or hash table or stream-based frequent item approximation algorithm. To approximate the directly follows relation, two data structures are used. One is the activity data structure, which contains the activity pairs, and we have the case activity data structure representing the last activity seen for a particular case. And we here have the drop-down list to choose from, different data structures. Here I choose forward exponential decay data structure, and this is for the inductive miner. I click Next, and I have the same panel for the alpha miner. I can choose, let's say, lossy counting with budget and a budget size of 1000. I click Next, and I have the configure model metrics panel which was a panel that was created for implementing the conformance checking parameter values, which is currently under implementation, and we leave this as it is, and we click on finish. And I will pause this to explain what we see here. We see two different panels, and we have no results to show yet as of now because I have paused it. And in the bottom of both the panels, we see a slider, a packets received label that displays the number of data packets that has been received from the stream generator. And then we see the update result button, and next to it we see the number of models label. So for this demo, I've chosen algorithm outputs to be generated after every 50 data packets that have been received. So when I click on the play button, I see here that after 50 data packets were received, I have a model generated. So at every 50 interval, I have models generated. So on the left, we have the inductive miner for using the forward exponential decay algorithm, and on the right we have the inductive miner discovery algorithm generated using the lossy counting with budget. So when I pause, I can go back using the slider model number 7, and here also I go to model number 7, and we can visually compare. We see on the screen here, I can also use the update result button to generate a model at a given point after a required number of data packets are received. So I click on update result at any random time, and I also get the models here. Currently the conformance checking parameter value generation is under implementation, and once that is implemented, we can have the fitness precision values for both the models to be able to analyze parametrically both the models that is generated. We have seen that we have visualized two process discovery algorithms for the streaming framework in ProM, and this implementation allows us to compare the discovery algorithms visually within the streaming framework. Thank you for your time.